other numbers you want to see you go over, have questions about? What was that? Okay. Not everyone is voting.
So fun.
72 on the back. Okay, so I'm seeing 5s and I'm seeing 3s. So, and those were majority. So we'll do those two. So if you did not do 4 and 5, I mentioned that earlier. If you didn't do 4 and 5 sometime today, make sure, or later, make sure you get those done. Soon in the next few weeks, we'll be doing 4 and 5, which means you'll be turning in that answer sheet. So keep that in mind. All right, number 3, you should have multiplied this fraction to everything on the inside, as well as this fraction to everything inside. Remember that with fractions, you multiply across. So 7 times 4, 7 times 16, 8 times 5, 8 times 1, and so on and so forth. So I'm going to write this out. You may have started to simplify this in your calculator, and that's fine. I'm going to write it out exactly as I see it. So we have 28 over 40, x plus whatever that was, 12, plus 3/10 x minus 30 over 1. And then we could start to simplify. Some of you, again, maybe didn't do this part and just simplified right off the back. That was fine. There's 28 over 40, divide both by 7. I don't know why I said 7. That's not what I meant. I meant 4. Was already simplified, and then this just becomes 6. So a little bit nicer. And then we need to combine our like terms. So we have x's and constants. When we combine these, we would be adding the fractions together. So 7 plus 3 over 10. And then combine these to get 8. And then this also simplifies. So all the fractions went away just to give you x plus 8. Questions on that? So make sure you have all that work. You, again, didn't need to write this. You could have done here. And then the rest of the work in the final answer. And then let's do 5. So this one we had to solve, distribute on both sides. So this is going back to what we did last class. We have negative 5x plus 15, bring down everything else, minus 2x equals 46, minus 4x minus 4. Combine like terms on the same side. You have negative 7x plus 15 equals 42 minus 4x. Then you had choices. You could pick whatever you wanted to move. What did we move first? Sure. If that's not what you did, don't erase. As long as you picked one of these, move them correctly, you should get the same answer. So if we move 7x to the right, we would be moving 42 to the left. You could do that at the same time, or you could do them in 2 separate lines. Negative, what was that? We should have gotten x equals negative 9 or negative 9 equals x. Doesn't matter the way you write that. Do we have any questions about that? So the majority was 5 and 3. So we won't do 2. Take out your notes from last class. We just have one last page we need to finish and that. Go all the way to the end where it says work problems. What we're doing after that. So starting with number 1. Find the value of x so that the rectangles have the same area. So again, we need a little bit of background knowledge. How do we find the area of a rectangle? Multiply the two sides, length times width. So we're going to end up doing that for both of these, but if the rectangles have the same area, how can we set this up? What's going to say this is the same as this? How could we say in math something is the same as something else? It's an operation. Or a math. So that means whatever we do here is going to equal whatever we do here. So we could set this up like length times width. It doesn't really matter which one you call the length or the width, but length is typically the longer side. So we're multiplying 12 and x, and that's going to be the same as multiplying 16 times x minus 2. So now that we know how to find the area, we know that it's the same, we set them equal, now we can solve. We have 16x minus 32. What would be our next step? How do we get all the variables to the same sign? Which one? Yes. So you could subtract either or, but subtracting 16 would help you get them all on the same side and not create an extra step. If you subtracted 12, this would be 0 equals the rest of that, and you would have to bring it back. So you would have created an extra step. And then divide. So that x equals 8. Now, this is just the answer to x. This is not the area of each rectangle. So if you put 8 in here and multiply, what would the area of both rectangles be? 12 times 8 is 96, and 16 times 6 is also 96. Questions on that one? Remember that once you have your equation, you can check that in Desmos in your calculator. In your calculator once you have an answer. And then in Desmos, you could check at any point in time. Alright, let's try this next one. Let's read through and find important information. Chris has saved twice the number of quarters that Nora saved, plus 6. The number of quarters Chris saved is also 5 times the difference of the number of quarters Nora saved and 3. Write and solve an equation to find the number of quarters they each saved. So what's important here? entire first sentence. What else is important?
What is the difference of the number of quarters Nora saved?
I'm also going to highlight the word is also. That's going to tell us how we're going to set it up. And then we are looking for, we have to write and solve the equation. And we have to find how much they each save. So let's start off with a variable. We know this is basically talking about all the amounts Chris has saved compared to what Nora has saved. So if we find how much Nora has saved, then we could go back and do the math to find Chris's number. So let's find a variable for Nora. I'm going to call that n. Remember that we have to be specific number of quarters. We can't just put Nora. Because we need to know what about Nora don't we know the number of quarters that she saved. And then how could we say that he saved twice the number of quarters that Nora saved plus 6?
2 plus 6.
N plus 6.
That's for Chris.
Right, so this is Chris's equation or expression based on Nora's quarters. How could we say is also? Equals 5 times the difference of the number of quarters Nora saved and 3. How would we write that part?
And then in parentheses, that's easy.
So we're only going to use one variable. 5 times the difference of the number of quarters Nora saved and 3. We are going to have parentheses. We are subtracting. So 5 times the difference, everything in parentheses, the number of quarters Nora saved, we have that as n and 3, so n minus 3. So now we have our equation, now we can solve. So we can distribute. And then we can choose what do we want to move first. That's not what you were going to go with. Go with whatever you were going to go with. The math should be the same. So we move 2n to the right. We can move 15 to the left by adding. And divide so that the number of quarters Nora saved is 7. And remember to be specific here, 7 quarters. Now to find Chris's number, we have to go back and put 7 into either this side or this side, does not matter. So I'm going to have you 5 tables, do this side, put 7 into this side, and you 4 tables, put 7 into this side. You should get the same thing. Do that. Put 7 in this part. Figure out how many quarters Chris saved.
There's not going to be that in this equation.
Correct. You're also not putting it in both sides. You're just doing one side. Because they'll be the same. What was that number? So we should have gotten 20 on both sides by putting 7 into either side. Questions on that one? You don't need to write what I just put in red, but you can if you so choose. Okay, let's do this last one. 2/3 of a number reduced by 11. Actually, I want you guys to try this last one. So take a couple minutes, try this one, work with the people around you, and then we'll come back and we'll talk about it. Okay. I will set up the equation, and then if anyone wants to come solve it, then you can do that. So 2/3 of a number, let's say our number is x, so it should be multiplied, reduced by 11, subtract 11, is equal to 4 more than the number. Anyone want to come solve this? I saw a bunch of different answers. So there were different ways to solve this. Some of you went about getting rid of the fraction, some of you started moving things. So if we started to move things, what did we move first? What did you say, Ken? Okay. It doesn't matter. In this, we can move both. So let's say we move 11 and then get rid of x. So in your calculators, you should have, or by hand, you should have been subtracting 2/3 and negative x to get negative 1/3 x. And then at this point, you could take this and multiply by the reciprocal. So that x was negative 45. If you divided by the reciprocal or multiplied by the same fraction, you mixed them up. So fix that. Do you have any questions on this? These were more so made up word problems. The problems we saw last time, 2 classes ago, those will be more like the ones you'll see on the test. You might see like one of these, but these will be more rare. Okay. So then what everyone is going to do for the remainder class is this. The first choice is yours, the second choice is whatever one you didn't choose. So there are 2 things up here. One is like a maze, on solving multi-step equations. Do all of it, raise your hand, I'll check it, and then you can either grab this or this first. This one's word problems. It's a front and back, it's 10 problems. Do all of it, I'll check your answer, and then you can grab the other. So whichever one you grab first is up to you, but then you have to grab the second one afterwards. So you're doing both regardless. You can work together, you can use your notes, you can use your calculator, you can use Desmos, but you have to show your work. Ask me if you need help. Do we have any questions? So go grab your first